Hi, and welcome to today's webinar. Thanks so much for joining us live. I'm Catherine Stapleton, webinar specialist at AWWA. And before we get started, I just want to go over a few tips and tricks to enhance your virtual experience in ON24. Please close any programs not currently in use. This will free up processing and increase bandwidth, speeding things up and strengthening your connection to prevent crashes. While technology glitches can happen, note that most common webinar issues can be resolved by simply refreshing your browser. If you do encounter a problem, such as frozen screen or loss of audio, please refresh the page before attempting to troubleshoot. As you explore the attendee console, feel free to move things around and adjust to your preferred view. All of the windows and widgets in your browser are customizable. Just hover over a window to display the toolbar, allowing you to minimize or hide, resize, adjust volume, and turn on closed captioning. Let's take a look at your toolbar. From left to right, the first icon is Presenters. This will open up your media player. Here, you can adjust the volume and turn on closed captioning. The Slides icon will minimize or maximize the center window with a live view of the presentation slides. Submit a question to the panel will open the question pane. We'll hold a Q&A session after the presentations, but questions can be submitted at any time. By default, you'll find the question pane located directly underneath the slides. This presenter information icon will open up speaker biographies and contact information for today's panelists. The purple icon will take you to AWWA's Events and Education homepage. Here you can check out upcoming webinars and events. Here you can access the attendee chat. We encourage you to use this tool to interact and share information with your colleagues. You can also reach an AWWA representative in the attendee chat. They're going to be available to answer any technical or webinar-related questions. This paperclip icon opens up your additional resources. Here, you can download a PDF of today's presentation slides. Reactions will allow you to share emojis during the live webinar. This thumbs up icon will open up the webinar survey. The survey will also pop up as soon as the webinar concludes. Once you've met the attendance requirements, this ribbon icon will appear, allowing you to download your AWWA Certificate of Completion. I need to inform you that the mention of specific products, services, or opinions expressed in this webinar do not represent AWWA endorsement. AWWA does not endorse or approve products or services. With that, I'll hand things over to your moderator and panelists. Thanks so much for tuning in and enjoy the webinar.
Hello, hi everyone. It's really good to see such a big audience joining today's webinar. And thank you for joining, and I hope that you enjoy it and find it useful. Today, we will explore how digital solutions and advanced sensor networks are transforming the way utilities operate, and we'll showcase how these technologies help optimize operations and improve decision-making by leveraging Metro Water Services' real-world experience and using digital solutions to reduce water losses, improve supply quality, and in summary, make data-driven and real-time decisions. From my side, I can introduce myself. I'm Jose Maria Santos. I'm the Director of Product Management for Xylem Vue. And joining me today is Justin Bowling. Justin, if you don't mind, please.
Yes, I'm Justin Bowling. I'm an engineer at Metro Water Services. Been with Nashville for about 12 years.
Great. Thank you, Justin. Okay, so let's start by reviewing now as a first step the role of the digital platform in this journey. We all may know that continuous evolution, improvement is in the DNA of every industry, and water utilities are no exception of that. Challenges that utilities face today, such as water scarcity, population growth, shortage of manpower, water quality regulations, just to name a few of them, are rapidly becoming more and more severe. And also that being more efficient, using assets more wisely, improving workflows and procedures, etc. These are all challenges that utilities have faced for years. But what is different now, and when utilities look at the future, it's no longer a choice, I would say, is the adoption of digital technology to help them overcome these challenges. Here's where Xylem focuses on and plays, I would say, a differentiation role while developing and enabling digital technology, as well as leveraging big data and artificial intelligence to change the way those challenges are solved. Some of these challenges can be or are mentioned here in this slide. Efficiently and optimally managing water infrastructure requires a holistic approach, okay, considering a vast amount of information which, in case it exists and is in good shape, will be scattered all over different systems and individuals within the utility. In any organization as well, there are significant challenges related to data. It is, I would say, business as usual to request information to different departments and wait some significant time and spend also some of it in back and forth data sharing attempts before the proper information and with the proper quality is available. In addition, communication shortages, sensor failure or faulty data, which in case is not properly managed, validated or standardized, can lead also to wrong outcomes or inefficient assessment. And unfortunately, this is also frequent. Also, to mention the construction, operation, and maintenance of water transport and distribution systems represent huge expenditures for water utilities, and typically their operation is carried out by using a reduced amount of information, usually limited to historical and real-time data available through SCADA, which limits the ability that operators have over the expensive infrastructure they manage, and what only gives them room to react to network issues rather than providing a proactive control. And the last one, today's water networks operators needs a solution that goes beyond SCADA, a solution that brings together operational and hydraulic engineering walls, because historical and real-time information is no longer sufficient in effectively operating and maintaining the fluctuating distribution networks. Okay. Also, to mention here that some of these technologies might be complex or difficult to understand in how they work and function, but that's also something to address. Then, when it comes to the insights, okay, here we are really thinking about, okay, how can we assist with some of let's say, these challenges? Maybe what systems and information is already being gathered that could be useful in these situations. So data platforms can empower decision-making by, firstly, providing a centralized network-wide view and allowing ultimately people to overlay different data sources. This means that data of different nature, like GIS, sensor information, word orders, BIM, or any other, can be put together in order to provide an holistic picture of what's going on in the utility, and getting the context from all this can really start to unlock these insights rather than looking at things in separate systems. Centralized data ensures its readiness, and making it safely accessible across the organization is not trivial. It requires significant investments in infrastructure, in software, maintenance, as well as staff training, trying to get used to new structures, application, processes, etc. Also, impactful decisions are made based on data, so it's key to ensure both meaningful information is considered and its quality fits the requirements. Okay, and then the next step alongside this is the third bullet point here on predicting conditions and optimal responses. So it's is there a way that that we can use these data sets maybe in combination with models in order to figure out, hey, without any intervention, here is what would happen in the network. And on the other hand, for example, if with an optimization that look at how we better control our pumps or our valves or any other piece of infrastructure, hey, is there any optimal response that we can leverage? Also, it's not mentioned in the slide deck, but it's not something to forget. This is cybersecurity. So cybersecurity needs to be mentioned here as well. In any aspect of our lives, we carry out countless of digital transactions daily without questioning any, let's say, security or reliability. The same principle should apply to digitalization of water distribution systems. Trust is in the organization in order to adopt their solutions. And given the role of the utilities in health and safety, ensuring cybersecurity in this platform is a must. It is essential to prevent threats, service disruptions, and potential risk in water quality. And for sure, data platforms embed that in their core and provide that to the users. Now, here, this is about getting there. Okay, so it builds the story a little bit from left to right. So we begin with physical assets and sensing, and here we can include, for example, flow, pressure, levels, availability of some of the assets in the network, etc. And as we consider those and bring them together for that unified visualization that I mentioned before, to get additional context, we can look at the platform and data integration. So this is where we may consider built connectors to connect those various data sources. These are ETLs, APIs, data stores that then we use to bring all this together in one place. And beyond that, visualization can then be enabled. And this is where actually you may get live dashboards telling you what it's happening and where in the network. You also may have here map overlays showing you the context of where some different pressure or flows are changing. And maybe then you get some reports that you do on a regular basis that can be automated, like, I don't know, customers affected by low pressure, water quality, etc. All this can be in form of interactive maps or charts, table, etc. So far in this journey, we have the data, we have the mechanisms to acquire, process, and store it, along with the capability of visualizing what is happening now and where. And beyond that, we have the analytics piece. Analytics are able to expand the here and the now, not only geographically, meaning that, okay, it enables the knowledge of what's going on at any location in the network, but also in time, providing context about the evolution of the network state given some forecasted conditions. For example, anticipating the pressure variation in an area, where a valve will be closed for some time, or the resulting impact on the level of service and so on, and how long will a tank, for example, be able to provide service according to the forecast of the consumption, for example. Beyond the analytics, the next step will be not only what's happening or what could happen under some circumstances, but also optimizations. Are the valve set points or are the pump on and off level something that we can leverage or that we can change, let's say, in order to improve the operation or reduce risks in potential problems now and in the near future? That's the kind of questions that we can ask here. And finally, the control, which sits above all this and allows the user to automate the decision-making process. So this is the process. This is how the platform can drive you from sensing to fully and proactively, and if desired, of course, automatically control your network. Let's now deep a bit into some of these challenges mentioned above, starting by the data silos. We'll be very briefing here, but I would like to now to introduce a very brief definition of silos. So to my mind, silos refer to organizational or departmental divisions that exist within the utility structure. And these divisions often result in isolated or segregated operational units that operate independently of one another, leading to inefficiencies, lack of collaboration, and at the end of the day, suboptimal performance. While specific statistics might vary by region, the challenges faced by water utilities in terms of organizational silos are pretty much global in nature. So across different regions, these or different reports also confirm that these silos are a major obstacle. And proof of that is that different or surveys, including different utility managers, repeatedly cite that isolated legacy systems as a barrier to digital innovation. Okay? In this slide, we just highlight some findings from recent studies and examples in the US, Europe, Middle East, and Asia. So I won't go over, let's say, all the information, but just leave it in there. And if any of you is interested in the references, I'm glad to provide that. Okay. So how silos can be manifest? So some common manifestation of the silos in the water utilities, as we can see here, is our departmental division, data fragmentation, communication barriers, lack of strategic alignment, and so on. All these factors might lead to negative consequences, like lack of an accurate, integrated and consistent view of the operations, high number of different workflows due to multiple apps, lack of real-time insights, lowering the decision-making process, or driving the utility towards a reactive operation instead of a proactive one. And these consequences will have an impact as well on the organization, like decreasing the staff effectiveness, empowerment, or morale, compromising the competitiveness, lowering the revenue, and compromising the financial viability of the organization. So breaking down these silos, promoting cross-functional collaboration is essential for optimizing the performance and ensuring the sustainable management of the utility. And but the utility have managed themselves so far, and the question here should be, okay, what is new to help them break those silos? No? So traditional systems usually consist in data structure, workflows, and software suites, always optimized for a specific department, and where anything beyond the department relies on manual individual interactions. Whereas digital platforms are integrated software solutions that serve as centralized hubs and for data management, analysis, communication, and this facilitate the integration of disparate systems and processes within the same utility. We can mention here differences in integration and interoperability, real-time monitoring and analytics, collaboration and communication, scalability and flexibility, and user experience and accessibility. Okay? The bottom line is that digital platforms represent a paradigm shift in how water utilities manage and leverage technology to optimize operations, enhance collaboration, and deliver value to customers and stakeholders. So by embracing this digital transformation, water utilities can overcome the limitation of traditional systems and unlock the opportunities for innovation and efficiency. Also, we mentioned as well limited visibility as another of the key challenges. It is difficult for operations to have a full view of the infrastructure they manage. And I will go very, very briefly over this, but there is a picture that I always like to show. I consider it might be very representative of what happens regularly. So usually the network might look like this. You have all your systems. Also, there's information coming from sensors that are deployed on the field, those colorful dots that we have there in the picture. When, let's say, deep diving on those or clicking on those in this case, you can get real-time information or historical information about those locations, what is that has really happening there, right? But the key here is that, okay, the operation of this expensive infrastructure, as we were mentioning before, is typically carried out by using that reduced amount of information, just the information that is in the dots, okay, that is accessible in those points. The rest of the network is not known, or is, let's say, barely known by the operators. So let's say really the picture that operators might see is something like this, which is very different. So at the end of the day, it's just known what is on those dots, okay, rather than how them are connected or which is the influence of those and so on, which limits a lot the capability as well to, let's say, proactively control or operate the networks. Okay, empowering utilities. So finally, in this section, we will just introduce how let's say the digital platforms can empower utilities to, let's say, mitigate those challenges and produce the expected outcomes. Okay, here in this case we will talk about our digital platform. One of the things that we will say is that it meets the utilities where they are in terms of digital transformation. And this is really key or important because it leverages the investments already done, and it serves as an holistic accelerator towards this holistic approach. For example, in that way, let's imagine that, okay, you want to start, let's say, with a clear picture of the network, and then you have data that is already coming from the SCADA, GIS, or field sensors. So we're able to get that information, standardize it, secure it, and so on, and display that on top of our platform. In the same way, if you have a real losses or consumption issue, additionally, we will get AMI information, and we will provide leak detection capabilities. If we want to move to operating losses, we will do the same, and we will just leverage the information to assess on the metering infrastructure, and so on and so on. So just being proactive, detecting leaks and monitorization, we leverage what are this information, connected to the platform, and so on. If we want to focus on emergency responses, in the same way, we can leverage models, if you have, for example, in this case, hydraulic models, in order to reproduce the behavior of the network with digital twins. And we have many other, let's say, similar use cases. We want to optimize treatment. We can leverage the information on the plants, chemicals, and so on, and provide plant management capabilities and so on. And on top of it, which is really important and also is breaking, let's say, another kind of silos that are being formed these days, is that on top of that, we have that service operations center, that layer that is unifying the feedback or the recommendations coming from all the pieces of the platform and providing a unified recommendation, which at the end is breaking down not just these silos of data, but also these silos of recommendation that now are appearing at any organization, given the different systems that are playing different roles in there. Moving on, I will just introduce briefly Metro Water Services. Metro Water Services, provides public water treatment and distribution, and also wastewater collection and treatment services to customers located in Nashville and a portion of surrounding counties. Also, it provides some water and waste services, trash and recycling for customers located in those 526 square miles. And finally, just to mention that the public drinking water system is also a vital part of the fire protection in the community. Moving on, Metro Water Services has two water treatment plants that serve the community, KR Harrington and Omohandro. This can treat up to 180 million gallons of water per day and deliver drinking water throughout over 3,000 miles of water main. And also the network is structured in 90 pressure zones, including 56 pump stations and around 37 reservoirs as well. What about managing these, let's say, complex distribution systems? I think that we are all aware, and we're all aware that of the dynamics and complexity of the water transport and distribution systems, how rapidly conditions changes and how challenges as well. So here we can name same kind of issues most utilities have, I would say. Ensure water quality from different angles, managing burst and leakage, and also pressure management to keep systems in shape and extend their useful life. So when it comes to managing these complex systems, the first step could be understanding. So it is having a full picture, as we said before, of what's going on in our network. This will serve as a foundation to clarify, which I consider very often one of the most challenging aspects of solving the water distribution issues, which is determining the main driver or drivers that are creating the issue itself. Many issues facing the operations of water distribution systems are difficult to resolve because the circumstances creating those issues are complicated and constantly changing. And several programs are available to aid in operation the distribution system, but these programs do not, let's say, paint the entire picture of what is happening in the distribution system in real time. As we mentioned, the information available in the utility is very heterogeneous. In this case, we have SCADA, we have hydraulic models, we have GIS, metering information, customer information as well, work orders, and so on. All these solutions are at our disposal in the utility and provide critical information on water distribution system. But it's important to mention that none of them are capable of telling the entire story, which still makes teams spend a lot of time figuring out the real cause of most of the issues. So by integrating key aspects of these systems and information into the solution, our platform, let's say, can lift on the water distribution system. So about our partnership, so Metro Water System Services and Xylem partnered in order to develop a real-time decision support tool for hydraulic and water quality distribution systems. But during the years, this approach has evolved, expanding to areas like leak detection, metering, etc. Xylem Vue, our platform, optimized the distribution operation by providing a flexible live water modeling solution configured to the Metro Water Services infrastructure. Okay? And the key about how it works is something that we have been repeating during the whole webinar at this point. So it collects the information from different systems like the SCADA, the drug model, the GIS, etc., process it and produce outcomes like the real-time visualization, analysis capabilities to spot the root cause of issues, etc. And this, at the end, will produce some benefits for Nashville, just reducing the response time, providing better responses to issues, etc. Now we're going to take some time just to go over some success stories here, and we will start by Brick Church pump station. So here, let's say the Brick Church pump station maintains let's say it's there to maintain reservoir level. So single pump usually does all this job, but around this date, specifically, it was observed that the flow increased from 25 to 50%, and the two pumps there started running. Even let's say when one pump ran after this event, the flow that was so strange remained, let's say, higher than before the event. Okay, so something weird was happening here. Okay, what was that? Okay, the station was appeared to be unable to maintain the reservoir level. Okay, and running the two pumps for some extended period caused actually an additional issue, which was the burning up of a transformer. Okay. Further investigation here revealed that in the morning of the 23rd of November, at that point, there was also let's say a leak, around the BRV. Okay, and the thing was that the leak caused a big drop in the discharge pressure of the BRV after the break. Okay, and after the break, even the flow, or we observed that the flow didn't come back to what was expected. Okay, so after fixing that, there still seems to be a problem. Okay, the flow at Brick Church starting to clean shortly, and thereafter, and it never dropped back down. Okay, and while addressing this, the leak, a pressure boundary valve was accidentally left open on the same day. Okay, and once the valve was identified, thanks to all this information put together, the conditions went back to normal. Okay, so that was one of the examples that providing or getting the right context helped the operators to quickly identify the issue and to know what was going on. Now we're going to jump into another case, Granite White Time Valley. Okay. In here, we can see that Granite White Time Valley pressure zone is this purple zone in the middle. It is including a huge amount of people, and also is served by different facilities. That we can see, we have 3 pump stations: Granite White, Time Valley Estates, and also Mandrive Pump Station, and a couple of reservoirs. We have Granite White reservoirs and also Time Valley reservoirs. What happened here in this case was that, putting together all, the information that was collected at the pump stations, there may be something that is jumping directly at your eyes. Again, you're here looking at June 15 from 6 p.m. to midnight. And if you just pay attention, you can see that, all the pump stations were getting a spike at the same time, which is 9:55 of the same day. Okay, you can see that here, and there. Okay. If we took a look at the reservoirs, we can see that Granite White is approaching its fill at 9:55 more or less. So the attitude valve that is represented at the bottom of the left-hand side picture. You can see that shuts exactly at 9:55, okay, more or less. And if we take a look at the Time Valley Reservoir, okay, it's not at this peak. You can see that it's still filling, okay. You can see that it is not at the peak at the same time, which means that the pump station, okay, is still on at that time, and because it's still trying to fill the tank. So this situation created a surge, and actually what's the root cause of the break in this infrastructure, okay? This, again, putting together all this information helped the team to diagnose pretty quickly which was the root cause of the issue here as well. Okay, so just as a summary, it might seem like okay, it's pretty I would say straightforward or obvious, but it wasn't so obvious until all the information was available and all the capability of being able to let's say synchronize the data of all the single sources and so on was put together. Now we're going to jump to the last case that we have here, and this one is related to water age, okay, and quality. So in here, say one of the capabilities of the platform, given its nature, is to be able, for example, to provide the information, let's say, related, to water age. So when we show this to the guys at the utility, first thing that someone just spot was that location. Why that location? It's pretty simple. It was an operator that okay, he was living in that area. Okay, and he wanted to know, okay, which is the quality of the water that I'm getting in my house. Okay, so he lives there, and he wanted to see, okay, the quality of that. We will focus here on Lilton Avenue and also Essex Avenue. So when checked, he could see that, okay, I'm getting pretty fresh water. It's not even 2 hours fresh water, the one that I'm getting at my location. But then he suddenly realized that, okay, my neighbor is getting much worse water than me. So it's getting water like 75 hours late. So or age. So the thing was like, hey, that cannot be possible. There might be something wrong. We just live a block away. So there's no way in which just one block away, this is the situation of the network. Okay, so here we can just start thinking, okay, what's going on? What's running here? So another visualization that is really important and that we can put together is the plant split view. This view is able to let you know, okay, which is the plant that is feeding each of the different areas of the network. In this case, you can see that, okay, the operation house was or is fed by, let's say, 100 in green, and his neighbor is fed by KR Harrington. Okay, so this might start giving us some context. 100% water coming from 100, and in the other case, the case of the neighbor, like, I don't know, 14% more or less coming from that plant. Okay, so okay, there may be something with the other plant. Okay, also take a look at they live in different pressure areas. So one of them, the operator is coming or is living in the city low pressure area, and his neighbor is on the let's say Porter Road pressure area. Okay, here we can see the schema of the distribution. So we can see that, okay, both plants can feed at the end of the day the same area, but also we need to take a look at what's going on. So for that, we have this picture. And if we, let's say, see how this trends in time, we can see this green area and this, let's say, red line, okay, that is, let's say, separating, okay, where the water is coming from Alejandro in green and where the water is coming from KR Harrington in purple. Okay, this point in time is 4th of June at 5:27, if I'm not wrong, and let's say the area where they both are is just served at this time by KR Harrington. Okay, we can see that in purple. So over time, we can see how that picture is changing and how the water is starting getting from the other plant. Okay, so we can see how different is the picture just 24 hours after that. Okay, so the picture has completely changed, and the water has already or is already gaming in the whole area from same plant. But we can still see here that there's a small area where velocities might be very slow and so on. That's the reason why the water is, let's say, having a much higher age. Okay, so there. Okay, and we can see the differences of that. So why this kind of analysis is important, and what can we do with this information? Imagine at some point that we get a customer complaint from both streets. They're just separated, as you saw, 1 block away. So imagine that we get a customer complaint from Lytton and another one from Essex. Okay, so the picture is very, very clear. If we are not able to have this kind of systems or this kind of information platform that is able to drive, let's say, the detailed picture here, okay, if we are until or if we have in front of us taste another complaint here, what could be the solution? Okay, we can increase the PAC, okay, at both plants, and then we can see what's going on with that and so on. Okay, but if let's say if we put together the context, if we put together that okay, the age of the water is not the same, okay, and the let's say the area where the neighbor was living, the water is 3 days old. In this case, increasing the PAC, that's not going to solve anything. Okay, that's not going to help. So what could be the procedure? So in that case, we can go with, okay, increasing the PAC in one of the plants, okay, just to remove the problem at Lytton, and a flushing exercise in order to get rid of the same complaint in the neighbor area. So the picture is very different and the solution is very different. And the only way in which that or the utility, the operations teams can provide the right response is by having all the information and by having, let's say, all the insights about how the network is working. It might seem that, okay, it might be the same neighborhood, it's the same, it's just a couple of blocks away. So it's just, okay, how the water works in that area is totally different and it's totally a different picture, okay? That's all that we had. So thank you very much. I hope that you have found that useful. And now we will get some answers and so on. So thank you very much.
If anyone has questions, please go ahead and submit them now. We're just looking over all of the questions and we'll discuss them shortly. Thank you.
Okay. Okay, I will go through some of the questions that we have been getting into the chat. Sorry, I will not be able. We will not be able to, let's say, to go over all of them. But we can review them and provide some answers. I was have one of the let's say. One of the questions is about if Xylem is providing the modeling services or support or so. So the question is that, okay, we can either work with already existing models that you have, or if you are interested, we can also provide those services. We'll go over okay, let me go. Okay, there's another one here in the network, in the chat. Sorry. How quickly does the water quality react to changes in the field, like pump being shut off and valves closed, etc.? So here. Something that I would like to add is that okay, the system in this case is providing updates every 15 minutes. Okay, so every 15 minutes you have a new picture of the network. Usually that can be configured and customized according to your needs or the frequency that is going to let's say to fit better your infrastructure or your information. Yeah.
I will add to that it runs the model every 15 minutes, but when a pump kicks on and off, we see that instantaneously when a valve closes. So the reservoir levels, that's probably a 30-second delay, and I think it runs the model every 15 minutes.
Thanks. Thank you. What else? Okay, there's another one in the chat about if there is a sandbox capability to test scenarios, such as what if you can simulate the different combinations. That's a pretty good question. That's it's something that is being incorporated into the application these days. So we already have the capability, and we are combining. We are let's say releasing that in the very, very short time. But yes, that's something that will be available as well. Okay, that's part of the suite of the, let's say, of the platform, and we are doing now is just putting and enable the capabilities as well. So Justin, there's a question for you as well. Okay.
Yeah.
The tool.
I'm seeing a question about the modeling software. We use gosh, I can't remember our model. I'm not the modeler, but it's our water model, and Xylem used our water model to marry them up. What was it?
CPA net.
Yeah. What was the other question for me?
The other, is there is a question just asking that getting or having with the two water plants, does it help to know where the line between them in the distribution system? So
Yeah, I mean, it goes back to if you have a water quality complaint or an issue that you're trying to trace back. If you know you're going to know the time of the complaint, you're going to know the area of the complaint. Knowing where that water came from, it can help you um, diagnose what the potential issue is, knowing the source of the water between the two plants. So that's extremely helpful to us. The laboratory uses that information often.
Okay, there are some other, I would say, pretty deep technical questions in the about connectivity and so on in the chat. So I will try to get an answer from the specialist, and I promise to get back to you guys.
I see a question here from Donald. How is water age determined? That should be a quick one.
Yeah. So yeah, the water age is one of the, let's say, of the parameters that is determined by the hydraulic modeling tool package, and it is determined taking into consideration, let's say, transport times and so in the model. Also, thanks for the question, but it's pretty, it's not in the slide deck, but there is another capability that help to identify if you have or where you may have a problem related to the water quality. But it takes the, let's say, the information at the tanks level, let's say at the tank locations. So we have some charts that are able to display the water age at the entry of the tanks and also at the residential time of those. So that will tell you, putting those together, if the water is taking so long in the tank, or if the let's say circulation of that is okay and so on. But just to answer the question, it's determined by putting together the flows, velocities, and pressure that are calculated by the hydraulic modeling tool embedded into the platform.
And that water age tool with the tanks has been extremely beneficial because it allows us to see, are we having age issues in the tank because the water is getting to the tank is already old, or is the tank not turning over? And we've made adjustments to tanks by letting them fall out more when we've got good fresh water coming in, but the tank's just holding water too long. So it's been beneficial for us.
Okay, about the integration work is required to utilize the, let's say, the solution. I would say, I mean, Justin can provide the real picture, so I will let him go for that. So Justin, there is a question about how much integration work is required to utilize the, let's say, the various levels of proficiency in the utility existing hydraulic models.
Okay. That's going to be really situational and depend on your utility. If you have a clean historian, meaning all the data that you think should be going to the historian is actually making it to the historian, and you have a robust SCADA system with a bunch of pressure and flow and all the things that you need to monitor your system are actually making it back to the historian, and then it on your end there's not a heavy lift, but we had to clean up some SCADA issues on our end. So it depends on how complex your distribution system is and how robust your SCADA system is.
Great. And yeah, there's another one just asking if if the multi-species water quality modeling available is available to predict rain or other need tree to growth and so on. That's not already available. Actually, at this point in time, we are doing a POC, okay, and with Nashville as well. And once we have the outcome of those, we will implement that for the rest of the network. That's one of the highest priorities that we have got, and that's where we will try to let's say to clear the picture and to implement it and have it available for anyone. But that's a tricky one. Okay? That's not something that's or it's not let's say a capability that you can I would say implement and will run. You need to know the network. You need to know exactly how the system is behaving and so on. Be sure that you're able to also calibrate and also to how to say that to make sure that you are getting the right picture. In the same way that the models are calibrated when it comes to pressures or even flows, needs to be calibrated according to that. Yeah. And that's not that I would say trivial. There's another question about AMI data integration. Okay. Rounding the data seems okay. So, okay, I'm not sure. I will skip that one. Sorry, we'll get back to you. Okay, the way in which we integrate, let's say, information is as we show before. We get the Go ahead.
I will say on that AMI question, we've done an AMI integration for leak detection. There's a module that Xylem created for us, and we also round up for billing. But I think the raw data, we also have the raw data that doesn't round up. So that particular utility, that raw data I would think you should be able to access that. That's not rounded up to 2000 CUM.
Yeah. And let me find another one. Many of them related to the technology that is used to do simulations. So in our case, the piece actually that is provided that is EPA net, okay, and that's it. If you are already using another one, it could be a matter of let's say extrapolating the information, extracting the model, and integrating that into our platform. Okay. Then
I'll address the meter life and the hourly reads. I think our meters push it every 4 hours, but then every 4 hours you get all of the granular data, so you can get meter readings every 15 minutes. It's just the push of the data that drains that battery, and then once it pushes every 4 hours or hour, then it backfills all the data for the calculations.
Okay, thanks. Okay, I think that's all. I think that the rest of the questions that we have got in the chat, I will require some assistance from the technical guys. So I will get back to you guys.
All right, thank you everyone so much for your time today. Make sure to download your certificate of completion if you meet the attendance requirements. And right when we close the webinar, a webinar survey will pop up. Your feedback is important to us, so please take a moment to share that with us. Thank you and have a great day. And thanks to our presenters today as well.
Thank you very much. Good one.